Hi everybody! Today we're going to talk about inverses. Now when you think about inverses, you can think of them like the little blue arrow at the top of your screen, the undo arrow. You press it and whatever you've just done becomes undone. And that's what inverses do. For instance, let's say you're brushing your hair. Brushing your hair is a function, because that makes perfect sense. And then let's also say that messing up your hair is a function, because again, we're making perfect sense today. In this example, brushing your hair, let's call function 1. Okay? And messing up your hair is function 2. Now if we do function 1, we can go from messed up hair to brushed hair. To go back to messed up hair, we just need to mess it up, which is function 2. So here we see a pattern where if we're at, let's call this point A. If we're at point A, if we want to get to point B, we have to do function 1. And to get back to point A, we can do function 2. So function 2 undoes function 1, and function 1 undoes function 2. So really, that's not right. They undo each other. So let's put this in some mathematical terms now. Let's say we're working with addition. What is going to undo addition? What is the inverse? Well, if you're adding something, to get rid of it, you subtract. Now, what's the inverse of subtraction? Well, if you subtract something, you're taking it away, so to add it back on, you use addition. What about multiplication? Same thing goes. The inverse of multiplication is dividing, and the inverse of division is multiplication. Same thing goes for a little bit odder functions, like squaring. If you square something, in order to get back to the original, you need to square root it. Same thing goes with cubing. That's a 3, by the way. But what if you get something a little bit trickier? What if you get something like sine of x? How do you take the inverse of that? How do you undo that? Well, the answer is kind of funny. The inverse of sine, the function to undo that, is just the inverse of sine. Let's go through an example. So first, let's just go through an example that we'll know very well. 3x plus 5 equals 9. Well, you have addition, and the inverse of addition is subtraction. We're solving for x, by the way. So we need to subtract 5 from both sides. And then the inverse of multiplication is division, so you divide both sides. But now let's get a little bit trickier and do it with sine. So let's say we had 60 sine angle B equals 15. Well, first we need to divide by 60, because we can't deal with that B until we get rid of the sine, and we can't deal with the sine until we get rid of the 60. Just gotten rid of the 60. Now we have sine of angle B equals 15 over 60, which if you divide by 15, if you factor out 15 on both the top and the bottom, you end up with 1/4. Alright, so now we need to get rid of this sine function. In order to get rid of it, we need to take the inverse, which, like I said, is literally the inverse sine. You can find this button on your calculator, or you could try to do it in your head. So you have the inverse sine of sine B and the inverse sine of 1/4. So let's write down what we know for sure right now. We know that we're going to have the inverse sine of 1/4, because that's what's left on this side. We don't know what the inverse sine of 1/4 is. That's going to equal whatever is left on this side. Okay, so now we're taking the inverse sine of sine itself. Now, if we know that the inverse sine undoes sine, we know that these effectively cancel each other out. They undo each other. So that way all we have left is our variable b. By taking the function inverse sine, we can get rid of sine on one side of the equation and solve for an angle variable. So if we go back over here to our chart, the inverse sine of sine is literally the inverse sine. Sometimes people get confused about when to use the sine function and when to use the inverse sine function, but there's a really easy way to figure out when to do each. So if you're starting with an angle, you plug that or substitute that in to the sine or cosine or tangent or whatever trigonometric function you're using. This can also include secant, cosecant, and cotangent. Out of that, you get the ratio. So if you go back again to what sine, cosine, and tangent are, you have your opposite over hypotenuse for sine, abbreviating here if you can't tell. For cosine, you have our adjacent over hypotenuse, and for tangent, you have our opposite over adjacent. Need more information about what sine, cosine, tangent are and where you get them from, please watch the linked video. So if you start with the angle, you use sine and cosine and tangent to get to the ratio. If you start with the ratio, you use the inverse functions, your inverse trigonometric functions, to get to the angle. And again, this works for all trigonometric functions. So you could have the inverse of cosecant. It's just what you use to get from the ratio back to the angle. And because the sine and inverse cosine undo each other, they are inverses. So, a quick review. Inverses mean undo. So the inverse of addition is subtraction, because subtraction undoes addition, and addition undoes subtraction. Inverse of multiplication is division. Inverse of squaring is square rooting. Inverse of cubing is cube rooting. And inverse of sine is the literally inverse of sine. And this works for all functions and really anything you can think of. It's time for me to make the screen that just jumped to this jumbled mess disappear by doing the inverse of it.